Okay, so I'm going to talk to you specifically about a use case around connecting to a CMMS or maintenance system. And so kind of getting down to, if we go back to that ISA 95 graphic, we're getting really down into that level 0, where we're connecting into potentially sensors. Those sensors could be, as mentioned before, could be internal sensors on, let's say, a machine itself. So we could be sensing, let's say, the load on a spindle is a great example of that. Or it could be auxiliary equipment. That auxiliary equipment could be, basically the coolant tank or the quality of the coolant. Those sensors that I mentioned before from the IO Link sensors, there's about 28,000 different types of sensors you can use to connect today, smart sensors, so to speak. Not limited to smart sensors, but it makes it easier to do that data transfer. Then in addition to that is an environmental sensors and conditions. So, really cool example of that is we have a customer that, they do paint and have paint lines as an example, and they have to abide by a certain standard. So the particulates and air are not violating the local EPA. And so by taking sensors kind of before and after that, let's say, filter, we can recognize, and customers, manufacturers can recognize when, let's say, that filter is going bad. So you're taking action at the moment when it's needed, and it's not too late, and you're not burdening staff to, take the measures to check, the filter all the time, every day. And then lastly, avoiding huge impacts and fines. So that's kind of an example of, more of a environmental type condition or an HVAC situation where we can gather sensor information. And then what we can do is take that and do condition monitoring and threshold monitoring. So be able to take that, basically that condition and set a threshold on there where I was supposed to have a red line right here, but just imagine a red line that is actually breaching that, high or low, and then producing, alarm as a result of that. It's kind of like it's our logical alarm that's happened. It's not even coming from, let's say, the equipment itself, although that could be a source of an alarm. And then lastly, taking that and alerting the right people. And so that could come in the form of a maintenance team. Others could be informed, of course, but passing that into, let's say, a modern maintenance system. This just happens to be one of them, but there's a multitude of them, or a simple system that we have customers do, just like as Cullen is mentioning before, unlocking that information and saying, let's just pass it into an Excel spreadsheet. Something as simple as that, and be very effective still at solving the problem without a huge investment into another system, right? So this is a great example of connecting into a maintenance system. Another example that is hugely beneficial is starting to monitor machine cycles or hours, whether that's legacy equipment or modern equipment. So modern equipment, we're talking about PLC and CNC controls. We're talking about, for legacy equipment, sensors that can be put on, such as a current transducer over a motor lead or a spindle lead, and tapping into relays as inputs to measure cycles and measure basically hours accrued against a machine. And that then can pass into these modern maintenance systems that allow you to collect over time the cycles and the hours that then can be used to do basically meter-based PMs or usage-based PMs, and super effective at collecting that over time historically, and then making business decisions off of that, such as what is an appropriate time for me to change out the oil or change out the fluid, or be aware of potentially a catastrophic failure on a spindle, as an example.